So now, here we have a PNP bipolar junction transistor. I'm using the 2N3906, and we wired it so that it will pulse every time we give it a signal. And we're not doing too bad right now. This mechanical switch, there we go, has a switch bounce, where we will give out multiple signals by accident, just because of a poor connection. So that's something to be aware of, basically with all mechanical switches. Now, we have PNP bipolar junction transistor there. The way it works is we turn it on, we get a little bit of current from emitter to base right there when we close the switch. Capacitors though don't pass DC current, so we got that brief current flow, but that's it. It will come to a stop. Then we have to discharge it. So when we release the switch, we have two resistors there, 100K and 100K right there, giving us a return path. And it's okay that they go to the positive supply. That's the only current path right there when we have the switch open. So now we're going to take a closer look at the schematic for this circuit, where no matter how long I press the button, we just get a brief pulse, unless there's switch bounce. There we go. And it was doing pretty good right there until I kind of purposely made switch bounce. So here's the schematic. We have a PNP bipolar junction transistor wired as a switch. I'm using the 2N3906. Any PNP will work, although they may have different pin layouts. But to turn it on, we need an emitter to base current path, which we will get when we close the switch. And 10K should allow enough current to probably turn the transistor on fully. The capacitor, though, does not let direct current flow through it, so that's very shortly lived. We'll just get a quick charge and then we'll be done. The transistor will turn off at that point. Now when we release the switch, we get current in the other direction where the capacitor discharges right there. So we're using, somewhat high value resistors there. Doesn't matter too much what value you use, but we want to limit the waste current when we have the switch closed. So now in the last short, we looked at the schematic more closely. We got the PNP bipolar junction transistor there. You close the switch, you get a brief amount of current turning the transistor on. You got to release the switch in order for the capacitor to turn off so that you can restart the process. Anyways, you end up with a pulse. And so we have the PNP bipolar junction transistor there, emitter up there, and then base there, we got our capacitor, and 10K resistor to let enough current flow through, probably to turn the transistor on fully, but very briefly as the capacitor charges. So when we release the switch, we need the capacitor to discharge to start over again. So there you can see we got a 100,000 ohm resistor coming up to the emitter, which goes to the positive supply. And then that's a direct connection to this 100K resistor that is coming to the base, the other side of the capacitor right there, so that we have a discharge path